Hello class, I have another example here of a Taylor polynomial. In this case, I want to let f of x be the square root of x plus 1. And we want the Taylor polynomial of degree 4 at x is equal to 0. And then, based on that, I want to approximate the square root of 0.9. So, the actual function for this is the square root of x plus 1, right? So let me just copy that over here. If we pop in 0 for x, right? F of 0, that gives us the square root of just 1. So this gives us a value of 1. So, the first derivative of this. I'm not going to write this too fancy since we're just going to be evaluating it. But the first derivative of f of x is 1/2 times x plus 1 to the negative 1/2. And if we pop in 0 into this first derivative, and let me just put the same notation on here so it makes sense of this being the first derivative. If we pop in 0 into that first derivative, we get a value of just 1/2. The second derivative of f at x is going to be negative 1/4 times x plus 1 to the negative 3/2. And if we evaluate the second derivative at 0, you would get a value of negative 1/4. We want degree 4, so we need to do this 2 more times. The third derivative of f of x is going to be 3/8 times x plus 1 to the negative 5/2. And the value of the third derivative at 0 is going to be 3/8. And lastly, for the fourth degree, so the fourth derivative of f at x, this is negative 15/16 times x plus 1 to the negative 7/2. And the value of that fourth derivative at 0 is going to be negative 15/16. So due to these fractions, writing this out is going to be a little, let's just say, on the weird side. But the fourth degree Taylor polynomial for this is going to be f of 0 plus that first derivative of f at 0 divided by 1 factorial times the value of x plus the second derivative of f at 0 divided by 2 factorial times x squared plus the third derivative of f at 0 divided by 3 factorial times x cubed plus the fourth derivative of f at 0 divided by 4 factorial times x to the 4th power, right? So, putting all this in, we have, this is 1 plus 1/2 over 1 factorial times x plus negative 1/4 divided by 2 factorial times x squared plus 3/8 divided by 3 factorial times x cubed plus negative 15/16 divided by 4 factorial times x to the 4th. So we could evaluate this done a little bit further to make it easier when we do the approximation. This is 1 plus 1/2 divided by 1 factorial. 1 factorial is 1, so 1/2 divided by 1, this makes a half, times x, minus 1/4 divided by 2 factorial, so 1/4 divided by 2, this makes 1/8 x squared, plus 3/8 divided by 3 factorial. 3 factorial is going to be the value of 6. So 3/8 divided by 6. This gives us a value of 1/16 x cubed minus 15/16 divided by 4 factorial. So that's negative 15/16 divided by 24. That gives us a value of negative 5/128 times x to the 4th power. And now we want to take that and approximate the square root of 0.9. But before just plopping something into this Taylor polynomial, this approximation of the square root of 9. Try this right here. Approximate square root of 0.9. Our original function here, and let me use a different color for this, was the square root of x plus 1, right? Before popping something in, we know the square root of x plus 1 is supposed to be equal to the square root of 0.9. And how does that happen? That happens when we have a value of x to be negative 0.1. That way, when we have negative 0.1 plus 1 under the radical, that will make 0.9. So we need to use this value here of negative 0.1 into every single one of these. What does that look like? So for this, putting in that negative 0.1 into each and every single one of those x's, this is going to make P, if I was on the right tool for this, this will make P sub 4 of negative 0.1, and that is going to make 1 plus a half times negative 0.1 minus 1/8 times negative 0.1 squared plus 1/16 times negative 0.1 cubed minus 5/128 times negative 0.1 raised to the 4th power. So if you were to put that entire thing into a calculator, the approximate value you should get for that is about 0.9486833594. And the actual value, if you put the square root of 0.9 into a calculator, that gives us a value of 0.9486832981. So this one only differs here at the end between this 4 and this 81 here at the end. So let me know if you have any questions or concerns. Thank you.